So I am going to talk to you about butterfly STDs. It's true. All right? So I'm going to give you just a tiny bit of background on some basic biological concepts. I'm going to introduce the theory of endosymbiosis, and then I'm going to get you guys super stoked about bacteria, all right? So I'm pretty sure that none of you sit around thinking about bacteria and get excited, but you should all know that 90% of the cells in your body are bacteria, okay? So you guys are all bags of bacteria. That's all I see out here, big bags of bacteria, all right? So the cell, the bacterial cell, though, is the simplest form of life, but it's also paramount to all other life forms. And I think the coolest thing about bacteria is the way that evolved into higher life forms. Through this process of endosymbiosis, one bacteria engulfed but didn't digest another bacteria, and they ended up like living happily ever after in these symbiotic relationships. These relationships formed eukaryotic cells, which then formed insects and us. So there are three different kinds of symbiotic relationships: commensalism, where one organism benefits, the other isn't affected; mutualism, where they both benefit; and parasitism, where one benefits and the other is harmed. Most endosymbiotic bacteria fall into those first two categories, but I think parasitism is pretty rad. So these bacterial symbionts can be transmitted and acquired in two different ways: horizontally from other insects in their populations, or from their environment. And then vertical transmission is when these bacteria are passed on from mother to offspring. So this is why I call this an STD, because sex is involved, okay? So I am super interested in an endosymbiotic bacteria that is transmitted in butterflies, and it is present in all life forms, or all the life stages, because it is transmitted vertically. This bacteria is called Wolbachia. I'm going to freak you out now with another fact, that there are 10 quintillion, here it comes, insects, individual insects in the world at every given moment. So right now there are 10 quintillion insects. And those are thousands of species of insects. 53% of those are infected with my favorite bacteria, Wolbachia. They are ubiquitous, and they're also super diverse. They have thousands of different strains, and they cause these crazy effects on their insect hosts, all these different reproductive manipulations, depending on the strain type and the insect species. But I am most interested in what is called cytoplasmic incompatibility. You're going to go away with that word tonight. And what it does is what happens is when you have an uninfected female, so the green sign here on the left, mates with an infected male, there are no offspring, so they're completely incompatible to mate. When the female is infected, all offspring are infected, therefore Wolbachia promotes itself to spread through these populations and then decrease the uninfected butterflies. So here's my butterfly, the Oregon silver spot butterfly. This butterfly historically inhabited coastal grasslands from southern Washington all the way down to northern California, but their populations declined severely, and there are only 5 populations left, and they are federally listed as threatened. So that's the sad part. So there are 5 extant populations. Mount Hebo is the largest population. It's stable. Everything's fine with it. And then there are these 3 other Oregon populations that are really small. And with small populations, what happens is we have inbreeding. We all know what happens with that. And also, that increases the chance for extinction. So these butterflies had been subject to all these different stresses. Invasive grasses outgrew their host plants. They had habitat fragmentation, degradation. And then in my research, I discovered that they were also infected with this bacteria, Wolbachia. So Oregon Zoo, Woodland Park Zoo, and the U.S. Fish and Wildlife Service came together and did some pretty heroic efforts and started this program, a population supplementation program. So people like me go out into the field, collect female butterflies, ship them off to the zoos where they lay eggs, they're reared over the winter, and then in the spring we re-release them back into the population in the hopes to increase genetic diversity, decrease inbreeding, and boost the populations. So in a successful program, we would expect that this really small population is here. We just put tons of butterflies into it, thousands, and then after a period of time, it mellows out and it becomes stable and then sustainable. But what we didn't know when this program started was that the Mount Hebo population was infected with Wolbachia. So that causes cytoplasmic incompatibility in these other populations. So we take butterflies from this population, and release them into these other small populations that need more butterflies. Well, because of the geographic isolation for the last few decades, these populations are now artificially being mixed, and we have accidentally introduced Wolbachia into some of these smaller populations. So this could be a problem, right? And I'll tell you why. So we would expect that with Wolbachia, if we have just a few of them in the population, that the population growth would be just fine, and everybody's compatible here on the left. And also on the right, if all of the butterflies are infected with the same strain of Wolbachia, they will also be fine because everybody's compatible, able to have sex. And I just said sex so you guys would continue to be interested. But in that middle stage, where there's not many of are compatible, this could cause the populations to crash. So I did some theoretical modeling. I won't tell you about it. But what I found was that if we introduce thousands of butterflies into these small populations, and even if there's just a small number of Wolbachia-infected butterflies, the populations will crash and potentially be driven to extinction. Okay, so why should you care? Well, do you guys know butterflies are pollinators? Also, remember I told you that 53% of insects are infected with Wolbachia, so my research can translate into how we manage insect pollinator species in the future. Also, butterflies have the most fantastic metamorphism that is one of the biggest mysteries of life. We don't know how it works still. So my point that I want to leave you with is that we focus so much on the large things, but when I told you in the beginning that these are the smallest parts and most fundamental parts of life, we need to remember when we're doing our research, whatever it might be, to remember those things and study those too. Thank you.